and it covers everything from graphing the trig functions to inverses to verifying trig identities.
So all of it.
And,
Okay.
yeah, yeah, and half angle and double angle formulas as well.
Okay.
So the first one, it's a trig identities problem.
Okay.
Tangent of theta minus cotangent all over tangent plus cotangent equals sine squared minus cosine squared.
This is a verifying.
Yes.
Well, whenever I see lots of sines and cosines in the thing, I'm inclined to want to turn the left into all sines and cosines.
Right.
So tell me what we have on the left. Instead of tangent?
I'm sorry?
Instead of tangent of theta, what should I write?
Sine over cosine.
Instead of cotangent?
Cosine over sine.
And then the bottom?
Sine over cosine plus cosine over sine.
Now we basically have to add or subtract these fractions. So what's the numerator become? What's the common denominator in the numerator?
Cosine times sine.
What's the top left have to be?
Sine squared.
And the top right?
Cosine squared.
Let's do the same thing in the bottom. So we have the same common denominator. And the top left, same thing, sine squared plus cosine squared. Now what?
You multiply the larger fraction by the denominator.
Yeah, in other words, essentially, whenever you have a fraction over a fraction, if the denominators are the same, you can cross them out. In other words, I can cross that out and cross that out. If the numerators are the same, you cannot do that. But if the denominators are the same, notice that if I flip the bottom and multiply, they're going to cross out anyway.
Right.
So I'm left with sine squared minus cosine squared all over sine squared plus cosine squared. Well, what's the denominator equal to? Sine squared plus cosine squared?
1.
That's how you get it.
Oh, okay.
Left there. I really didn't want to write on the right side. I'd rather have gone all the way down on the left, but you get, in other words, I didn't want to, didn't have enough room to do that, so I did it.
Okay.
And frequently that's what you have to do. I'm not even positive that this is the most efficient way to do this one. There might be something else that I missed that we could have done with this, although I don't think so. Maybe multiplied by the conjugate, but even that I don't think would be easier. So it's almost never wrong. If you're looking at some sines and cosines in the thing, regardless of which side they're on, it's almost never wrong to convert everything to sines and cosines and go from there.
Right.
All right.
Okay. Next one is tangent minus cotangent over tangent plus cotangent plus 2 times cosine squared equals 1.
Well, I think we're going to do exactly the same thing.
Yeah.
In other words, this whole thing we just proved equals sine squared minus cosine squared, correct?
Yes.
Then if we add 2 cosine squared to it, we get sine squared plus 1 cosine squared. In other words, we have to go through that same process where we convert the tangent and cotangent to sine over cosine and then do the algebra. But since we just did it, let's not do it again, because I'm sure you got a lot that you'd like to cover here.
All right. So, this next one, it's cotangent of inverse sine of -√2 over 3. And find the exact value.
What's our first step?
I suppose find where -√2 over 3 is.
Our first step is, let's call that an angle, first of all. You
Right.
know that inverse trig functions are equal to angles. Okay. And now what's the next step that I've called that a angle?
Find what quadrant it's in.
Draw the triangle. Well, okay. Yeah, what quadrant is that in? I don't have a problem with that as the next step.
Quadrant 4.
Yeah, fourth quadrant. Okay, now we bring our triangle in. And label theta. And label 2 of those 3 sides.
The opposite side is 1, and the hypotenuse is...
I'm gonna call you, William.
Okay.
Hi, Mr. Kent. Is that better?
Yeah, it is. Let me turn my volume up a little bit on my phone. Okay. All right.
Sorry, I was looking at the wrong problem.
Okay, is this the problem we're on?
Yes.
Okay, dimension this triangle.
So the opposite is √2 and hypotenuse is 3.
Yeah, for the moment you can kind of ignore that negative sign. That negative sign was important, but only to place the quadrant. Now what's the bottom side?
√7.
Now what's the cotangent of theta?
√7 over √2.
And finally, what is the sign, the plus or minus sign in the fourth quadrant for cotangent?
Negative.
And you told me your teacher didn't care whether you rationalize that or not?
Correct.
Unless it's multiple choice. Is this a multiple choice test? Okay. Because if it were multiple choice, then you'd want to make sure that you recognize that that's the same as root 14 divided by 2. In other words, if you were multiple choicing, that might be the answer right there on your multiple choice.
Right, okay.
Okay? But as long as he doesn't care and you don't have to rationalize it, that's the smartest thing I've heard about trig in a long time. Okay, what else you got?
Sine of inverse tangent of -3.
First step?
Draw the triangle.
And?
So the...
Gotta label theta.
I'm sorry?
You gotta label theta.
Right.
In other words, if I don't label theta, theta could be up there. And
Right.
it will matter. So the first step that I really like is making sure you understand that that thing is an angle. So we'll call it theta.
Okay.
And then we'll label theta here. And now we can either dimension the triangle or figure out what quadrant we're in. What quadrant are we in?
Quadrant 4.
Again, okay. Now dimension the triangle.
The opposite side is 3, and the adjacent side is 1.
And now the hypotenuse.
Root 10.
And now what is the sine of theta?
3 over, -3 over root 10.
All right. Good.
All right.
Math is really all about memorizing methods.
Right.
It really is. If you can memorize a method, then you're not ever going to go wrong. And the method has 4 precise steps to it. Just always do it the same way.
Okay.
Now it is a little different if you have the inverse trig function of a trig function. That's slightly different. You don't solve that quite the same way. You don't draw a triangle.
Can you give me an example of that?
Sure. About the inverse sine of the tangent of pi over 4. In other words, this is not an angle. That's a number. Pi over 4 is the angle.
Right.
So in this problem, we have to work from the inside out. What's the tangent of pi over 4?
1.
Now, what's the inverse sine of 1?
Pi over 4.
No. This is one where you can't really use those 2 triangles,
Right.
but you can use the graph of sine. Well, where does this occur? Right there.
Pi over 2.
Yeah, that's the answer. And it's positive pi over 2 also. I guess it's always going to be positive. Now, if this was a -1, then the answer would be negative pi over 2. And that's an interesting distinction, actually. Notice why the answer is negative pi over 2 and not 3 pi over 2. In other words, if we do nothing but look at my graph, then you would say that the inverse sine of -1 would be 3 pi over 2. But the fact is that it's this point right there. which is minus pi over 2. Remember, when they restrict the domain of the sine function in order to come up with the inverse sine, they restrict it from that point to that point. Okay? So when you're taking the inverse sine of -1, you don't get 3 pi over 2. You get minus pi over 2. Now, technically, I suppose they're both the same answer. But if you actually do that in your calculator, it will give you minus pi over 2 or minus 90 degrees. It will not give you 270 degrees. Understand? I'm not sure you would necessarily lose points if you put 3 pi over 2, because
I think my teacher's policy is that we would.
You would lose points?
Yeah, just purely because the concept that inverse sine does not go through quadrant 2 and 3.
All right. Although, yeah, okay, no, I like that. That's not really in the third quadrant, 3 pi over 2. So technically, it's coterminal with minus pi over 2. But technically, when you're taking inverse sines of positive numbers, you're in first quadrant. Of negative numbers, you're in fourth quadrant. Well, that technically is not fourth quadrant either. So I'm not sure necessarily that these two answers are different. I don't think you would lose points there, to be honest.
Okay.
If you put 3 pi over 2 instead of minus pi over 2. It's just that your calculator is always going to give a negative angle. So to be consistent with your calculator, you might want to always do minus pi over 2. At least I think your calculator will give you minus 90 degrees there and not 270 degrees. Haven't actually tested it, but. All right, what else?
Okay.
One thing you and I have never done is double angles and half angles.
Yeah,
Let's make sure we do a few of those.
I've got a few of those.
Okay.
In just a minute. Okay, so this one says graph the function and identify the domain, range, and asymptotes.
Okay.
Y equals cotangent of x plus pi over 4, all in parentheses.
How do I draw the non-transformed, in other words, what's y equal cotangent of x look like?
It crosses the x-axis at 0, or it crosses the point of origin.
Okay, so how many asymptotes?
Yeah, every pi over 4.
Well, every pi.
Every pi.
In other words, if we're talking cotangent of x, then I'm going to draw that in red. That's pi. That's 2 pi. Cotangent is always decreasing. So here's 2 periods of cotangent. And that point is pi over 2. Now, what's the difference between my parent function and this function?
A phase shift.
Which way and by how much?
To the left, pi over 4. Or
Okay.
Pi over 4 to the left.
Okay. So, in green, rather than even graphing the original function, I forgot, my favorite method now, is to figure out where it starts. Well, if I'm moving it pi over 4 to the left, then my new vertical asymptotes are going to go through that. And what's the next vertical asymptote going to go through?
3 pi over 4.
Yeah, right there. 3 pi over 4. And then the curve's going to look like this. So, let's talk about domain. They wanted to know the domain.
Yeah.
Well, what is it?
All real numbers except k pi over 4. No. I don't remember how to state it. It's all real
Well,
numbers except
the way to figure it out is let's list them, and then we can see the sequence. In other words, it can't be this. It can't be this. What's the next one that it can't be?
7 pi over 4.
Okay. Now we're seeing a sequence. Next one's 11 pi over 4. Okay, so now we have to figure out how to take that sequence and talk about it. Well, what is it? Minus, list the first one, can't be that, plus what? N
N pi, right?
Right, n pi. And then if you check it, well, when n is 0, you get that. When n is 1, you get that. When n is 2, you get that. 3, and so forth. In other words, once you use this n terminology, it's a good idea to at least check a couple of them. What's the range?
Negative infinity to infinity.
We got our vertical asymptotes, we got our range. What else did they want?
That's it.
Okay, they didn't want to know this 0 right there?
No.
Okay.
Okay. Y equals 2 times secant of 2x.
There's no phase shift here, so I will graph the parent function. Now, the parent function is y equals secant of x. So it's going to sit on the tops and bottoms of cosine. So therefore, if that's 1 and that's minus 1, then the secant is going to look like this. With me?
Yeah.
Okay. And there's going to be a vertical asymptote right there. And right here. Notice you're going to have a vertical asymptote every pi because the period of this entire function normally is 2 pi. In other words, it has the same period as cosine. To draw the original secant of x, to draw one full period of it, you got to go from minus pi over 2 to 3 pi over 2. Okay. Now, what's the consequence of this 2? I hate it when they use the same numbers.
The period changes.
Okay. What's the new period?
Pi.
Okay. How does that affect my graph? In other words, in red, let's do y equals secant of 2x.
It's horizontal stretch.
Horizontal shrink. Remember that it does the opposite of this 2. The leading 2 is a vertical stretch. But when your B, which is this 2, when B is greater than 1, it's a shrink horizontally. Just remember it goes the opposite of verticals. When this number is greater than 1, it's a stretch. But when this number is greater than 1, it's a shrink. Now, how that looks is everything shrinks to the y-axis. In other words, I just don't start from the right and push it that way. That's not the way to do it. The way to do it is something that would result in this. No, that's not right either. Hold on. This one is correct. In other words, start from the y-axis in terms of your shrink. Well, if this red is correct, then the next red has to go like that. In other words, my new asymptotes for secant of 2x do this. You following me?
Yeah.
Okay. In other words, my period is no longer 2 pi, my period is pi. And I also no longer, in other words, I'm now going to go from minus pi over 4 to 3 pi over 4, which is a period of pi. So the red would represent secant of 2x. The last vertical stretch is actually the easiest one to do. What does that do?
It changes the apex of the curves.
Okay, where do they go? What's this? Yeah.
Plus or minus 2.
Right, it goes, instead of plus or minus 1, it goes plus or minus 2. So now, the green should be your final curve. In other words, y equal 2 secant of 2x would be my green curve. And what else did they want to know here? Your asymptotes?
And domain and range.
Okay. Well, same as the last problem, I believe. Let's see. Domain is all real except what?
Negative pi over 4 plus k pi over 2.
Good. Let me think about that for just a second. Yeah. Yeah, that's got to be right. Okay. All right. What else?
Okay.
Oh, I'm sorry. Range was all real. Did they want anything else there besides domain and range?
No, that's it.
Okay.
Okay, now double and half angle formula.
Okay. I was going to go there if you didn't.
Yeah. So, the first one is sine of 195 degrees.
All right. You've had sum and difference also, correct?
Yes.
sine of 195 degrees. So we have sum and difference to deal with. We could use double angle or we could use half angle. Well, let's see. Can I separate that angle into two angles that I can figure out without a calculator? The sum or difference? How about the sine of 225 minus 30? In other words, the sine of 225, that's a 45-degree angle in the third quadrant. And the sine of 30 is a common one. In other words, we can figure out both of these without a calculator.
Right.
Now, let's just play with other possibilities. It's not double angle because then the angle would have to be 97.5 degrees. Well, I don't know that, so I'm not going to use the double angle formula. I'm not going to use the half angle formula because then the angle would have to be 390 degrees. Actually, I could use the double angle formula. Is there are you supposed to use the half or double angle on these?
Yeah, specifically.
Well, then let's use the double angle, or the half angle rather, instead of the sum and difference. But you can see that I could use the sum and difference, right?
Yeah.
Okay, but instead we'll do it the other way. And the way to do this is always write the angle you're talking about like this. That's 195, right?
Yes.
Okay. What's the general formula for the sine of theta over 2?
Plus or minus the square root of 1 minus cosine of theta all over 2.
All right. So here's theta is 390, right?
Yes.
Okay. So what's this? We'll get to the plus or minus afterwards. We're going to choose one of these. Well, let's go ahead and choose it. 195 degrees is in which quadrant?
Quadrant 3.
Sign positive or negative there?
Negative.
So that determines whether we use the plus or the minus.
Okay.
Okay? Now, 1 minus, what's the cosine of 390 degrees?
Root 3 over 2.
Always divided by 2, and this is very common algebra that you're going to have to do always, because it's always 1 minus, and the cosine of the angle is usually a fraction, and then you're dividing it all by 2. So what's this algebra work out to be? Start from the top, the numerator.
2 minus root 3 over 2, and then all over 2, and then you multiply the numerator by the reciprocal of the denominator.
Okay, which makes it all over 4, right? In other words, if I reciprocate the denominator, it becomes 1/2. When I multiply that, it all becomes 4 as a denominator. Got that? Before I erase it?
Yeah.
So this ends up being 4. Okay. Now, that answer can actually be simplified. How can I simplify that? You might lose points if you put this answer in. You might not. It depends on your teacher. Is there anything I can take outside the radical sign? You see any perfect square numbers?
Yeah, 4.
Okay, let's take out a half. And what is left behind is just 2 minus root 3.
Okay, right.
Which is an interesting answer because you have a double radical sign, but that's also frequently the case whenever you use half angle or double angle, is you end up with 2 radicals in your answer, one inside the other.
Right.
But yeah, like I said, I'm not sure you have to go to this step here, but it is simplified a little bit. I would think that your teacher might insist you do that step. You might lose a point if you were to give this answer here.
Okay.
Okay. I'm a little curious as to what I would get if I did it using the sum and difference. In other words, it is the difference of 225 minus 30. It's hard for me to imagine that I'm going to end up with a radical inside of a radical with that other answer. But it should be the same number. Anyway, we won't worry about that. Do you have sum and difference on this test? Is that something you're going to be tested on?
Yes.
Yeah, I was going to say they usually teach you sum and difference before they teach you double angle and half angle.
Yeah, they did.
So if they didn't specify to use double or half angle, then I might do it this way. What did I say? I said 225 minus 30. And the sine of A minus B, what's that equal to? What's the general formula?
Sine times A times cosine of B minus cosine of A times sine of B.
Yeah, which is negative root 2 over 2 for the sine of 225 times the cosine of 30, which is root 3 over 2 minus the cosine of 225, which is minus root 2 over 2 times the sine of 30, which is 1/2. Interesting. I don't think we end up with a radical inside of a radical there. It's interesting that they're the same answers. They have to be. What do we end up with? We end up with minus root 2 times root 3 over 4, all minus a minus root 2 over 4. Well, it's interesting because what we really have there is 1/4 times root 6 plus, no, it's root 2 minus root 6. What's interesting to me is that that's the same number as that, even though there's not a radical inside of a radical. Okay. We won't try to answer that problem tonight, but I don't think there is a problem there. I think that both of those were the same numbers. All right, what else?
Okay, yeah, so sine of A equals 3/5. Cosine of B equals -12/13, where A is greater than or equal to 0 and less than or equal to pi/2.
Okay.
And pi is less than or equal to B, which is less than or equal to 3 pi/2.
Pi is greater than B and less than or equal to 3 pi/2?
No, sorry.
B is in the middle. Oh, let me write this again here. For some reason, I can't even think about it unless I write it like this. Is this what you meant?
Yes, yes.
Okay. And what do they want to know?
Cosine of A plus B and tangent of A minus B.
What's the general formula for cosine?
For the sum and difference?
Yes.
Sine of A times cosine of B. Oh, no, sorry, that's sine.
It's cosine, cosine. Remember, it always starts out cosine, cosine.
Okay. Right.
And if it starts out cosine, cosine, it's got to be A and B. And then this sign is always opposite to that one. So it's minus, and the rest of it's got to be sine A, sine B. The way I remember these sum and difference is you have two cosines and two sines. And they teach you this one first, oddly enough, and the sine second, right?
Yeah.
And the reason they do is because it's easier to memorize, the cosine one. The cosine is crystal clear. It's cosine, cosine, sine, sine. Whereas the sine one is not quite so crystal clear. You know there's two sines and two cosines there, but is this B or A? Well, it's B. And then the sine, and then it's the opposite, so the rest of it is clear. But the cosine one is actually a little easier to memorize. You can't really get it wrong.
Right.
Okay, so let me erase the sine one. And let's fill in. What's the cosine of A equal to? In other words, one of the most fundamental things of trig is if they give you one trig function, you can figure out all six of them. So all you need is one. What do you have to do?
Make a triangle.
Okay, so let's make a little triangle right here. And label A. It's got to be a right triangle. So that's got to be 3, that's got to be 5, that makes that 4. And we know we're in the first quadrant. That's first. So what's the cosine of A?
4/5.
What's the cosine of B? Well, they gave it to us, minus 12/13. What's the sine of A? They gave it to us, 3/5. What's the sine of B? Here, make another triangle. Label B. Dimension B based on the fact that the cosine of B is 12/13. That makes this side 5.
Okay.
And which quadrant is this in? Is B? Between pi and 3 pi over 2.
Quadrant 3.
Okay, so it's third quadrant, which makes the sign what? Positive or negative?
Negative.
-5/13. You with me?
Yeah.
Okay. And now that's just algebra, the rest of it. It is a negative, well, let's go ahead and do the algebra. It's not that hard. We have minus 48/65. Two minuses are going to be a plus 15/65, giving us minus 33/65. And that cannot be simplified. See how I got all of those?
Yeah.
Okay. Now, let's talk tangent. What's the general formula for tangent?
Tangent of A minus tangent of B.
Well, not quite. That's different than what this is. This is the tangent of, the argument is A minus B. That incidentally is not the same as tangent of A minus tangent of B. See why?
Yeah. Okay.
Okay, in this case, we're subtracting the angles first, and then taking the tangent of that net angle. Whereas if you took the tangent of A minus the tangent of B, that's something altogether different. That's the difference of two different ratios. So what's the difference formula for tangent?
Tangent of A minus tangent of B.
That's what you were giving me. My apologies. Okay.
All over 1 plus tangent of A times tangent of B.
I thought you were reading this to me. You were giving me the identity. You were ahead of me, that's all.
Sorry.
It's okay. Now, we can still use these two triangles. What's the tangent of A?
3/5.
Not 3/5. Tangent of A.
Oh, sorry. 3/4. 3/4.
Okay, and it's positive.
Yes.
What's the tangent of B?
-5/12.
Third quadrant. What's tangent in the third quadrant?
Oh, it's positive. Okay.
Right. So I don't want to add an extra negative sign there. Okay. All over 1 plus 3/4 times 5/12. And then again, tell me how to do this algebra, because you do need to simplify this.
Yeah. So multiply 3/4 by 3, and you get 9/12.
Okay, so this becomes 9/12 minus 5/12. all over what?
1 plus 5/16.
Okay.
Oh, okay.
No, you did it right. You simplified it. Oh, you simplified. You did exactly what I always tell everybody to do. Okay. What's the next step?
Then it becomes 4/12 all over. Should we make the denominator a
Common denominator. You have to add 1 to 5/16. And you want it to be an improper fraction, not a proper fraction.
Right.
So what's the new denominator?
21/16.
Okay. Now you flip and multiply, so we got 4/12 times 16 over 21. And let's see, I can do, this is, let's see, if I divide that by 4, that becomes 3, and that becomes 4. I'm multiplying. So now I got 16 over 63.
Yeah, that's it.
Don't think that can be simplified. This is divisible by 3, but this isn't. So that looks like a final answer. Yeah, I suppose I could have simplified my 4/12 into 1/3 also. Wouldn't have mattered. Wouldn't have mattered. Yeah. All right.
All right, so using the sum and difference formulas,
okay.
Find the exact value of sine of pi over 18 times cosine of 5 pi over 18 plus cosine of pi over 18 times sine of 5 pi over 18.
And what they're basically looking for here is to make sure you're recognizing the right side of the sum and difference formula.
Right.
Of which one? Is this sine sum and difference or cosine?
Sine.
So it's the sine of what?
Sine of pi over 18, or I guess 6 pi over 18. Would you?
Yeah, plus 5 pi over 18. Let's write it like that. Which gives you 6 pi over 18, which is the sine of pi over 3, which is 60 degrees, which is root 3 over 2. And all of these are first quadrant angles. Although we never really noticed that we didn't ever have to figure out what the sine of pi over 18 was. Or cosine of 5 pi over 18. Because all we needed to do was recognize that we were looking at the right side of the sum and difference for sine.
Right.
And then it turns into a nice, simple angle. All right, what else?
So same thing, but cosine of 5 pi over 12.
Let me guess, times cosine of...
No, that's it. Just cosine of 5 pi over 12.
Oh, and does it tell you how they want you to do it? Because there's a couple of ways we could do it.
It just says using sum and difference formulas.
Okay. So give me two angles that would either add or subtract to that. In other words,
2 pi over 12 plus 3 pi over 12.
yeah, both of which, that's pi over 6. That's, okay, so tell me what the rest of it should read.
Cosine of 2 pi, or pi over 6, I guess.
Mm-hmm. You might as well reduce it now.
Yeah. Times cosine of pi over 4.
Okay.
Minus sine of pi over 6 times sine of pi over 4.
Okay, let's fill in. What's cosine of pi over 6?
Root 3 over 2.
Cosine of pi over 4?
1 over root 2.
Minus sine of pi over 6?
I suppose it would be easier to write it as
Root 2 over 2. I agree. Mm-hmm. That gives you a common, well, you know what, it's not going to matter. Because we're multiplying. In other words, if we were adding or subtracting, definitely it would matter. Because we would have to come up with a common denominator. But I'll still write it like that, just because it doesn't hurt anything. And sine of pi over 6?
1/2.
Sine of pi over 4?
Root 2 over 2.
Okay. So, it's a pretty common answer. I can't tell you how many times I've seen this answer. What's the final answer?
Root 3 over 16.
No.
Oh, no.
Multiply tops and bottoms. What do you get? What do you get for this part here?
Root 6 over 4.
Okay. Now what do you get over here?
Root 2 over 4.
Okay. Now, there's nothing wrong with that answer at all. You could write it, obviously, I'm subtracting, so I only need one denominator, and it's common, so I prefer that answer.
Right.
But it's amazing how often you get root 6 minus root 2.
Yeah, that shows up a lot.
It does. It really does. And that's because of how everything is either root 3 over 2 or root 2 over 2. Not everything, but a lot of your common angles are.
Right.
Okay, we got just a few minutes. You got one more that you have questions about maybe?
Yeah, so going back to half and double n angle formula.
Okay.
Just using those two, or not those two,
Okay.
those ideas. Find the exact value of tangent of 9 pi over 8.
Well, let's see. If I took half that angle, that's 9 pi over 16. But I don't think I know that one. So I don't want to do the half. What if we doubled it? What's the double? That becomes 18 pi over 8. If I took away 2 pi, subtract 2 pi from that, and I've got pi over 4. And I do know that.
Oh, right.
Okay, so the way I want to set this up is I want to make it, what goes in my argument? What's the best way to write it?
Tangent of 2 times 9 pi over 8, I guess, right? Or would you just put tangent of 18 pi over 8?
Here's the way I'm going to write it. 18 pi over 8, because I know that one, divided by 2. Is that not the same thing? That's,
No,
in other words, what you're trying to write in the argument is 9 pi over 8. Only you're trying to write it as an angle that's divided by 2. And now I have it like that. Okay? So this is theta. 18 pi over 8 is theta. Okay, what's the general formula for tangent of theta divided by 2?
1 minus cosine of theta over sine of theta.
Really? It's not the square root?
No. Oh, sorry, I was looking at the wrong one. I was looking, no, that is the right one. Never mind.
Hold on a second. This is one that I rarely do, so I'm not sure I have it memorized, but the way I have it memorized is not what I'm seeing here. So, let me look it up. Do you have it written in front of you? The half angle formula for tangent? What's it say? What's tangent of theta over 2?
It's equal to 1 minus cosine of theta all over sine of theta.
Really?
Yeah, but it says it's also equal to sine of theta over 1 plus cosine of theta.
Oh yeah, that's a very common trig verifying identity. In other words, they frequently give you this problem right there and say verify that that's equal to that. All right. So we don't need both of them. We can just use this one. But theta is what? Theta is 18 pi over 8 or pi over 4. Right?
Yes.
In other words, 18 pi over 8 is not in the unit circle. That's outside the unit circle. So we need to subtract all multiples of 2 pi from it to get pi over 4. So now it's 1 minus the cosine of pi over 4 all divided by the sine of pi over 4. Which is what? Fill in everything.
1 minus root 2 over 2 all over root 2 over 2.
Okay. What's the numerator become?
Uh, 2 minus root 2 over 2. And then multiply that by 2 over root 2, like flip up the denominator.
Okay, which means I really can just cross out my denominators.
Yeah.
And I end up with this. 2 minus root 2 over root 2. How come I don't remember that being the half angle for tangent? I guess it's because I rarely get half angle tangent questions. Yeah, the sine and cosine are hard enough to remember for a half angle. All right, William, you good to go?
Yes, great. Thank you very much.
You're welcome. Good luck on your test.
Thank you. I'll probably schedule another session for tomorrow night as well.
That sounds fine.
Okay.
Okay, talk to you later.
Have a good night.
Bye-bye.